Today we're going to discuss acceleration. When you're talking about acceleration, there's some things you should know. So far we've spoken about speed, okay, and that's how much distance you cover in a specific amount of time. Remember the speed triangle was distance over time. And just a refresher that distance was generally measured in meters, time in seconds, and speed therefore in meters per second. And then we talked about velocity, and velocity, as you remember, is speed with a direction. So speed might be 55 meters per second, whereas velocity would be 55 meters per second north. Okay, so it's a vector quantity because it has both magnitude and direction. Acceleration is a measurement of the rate at which velocity changes over time. You might ask yourself, really, what does that mean? Well, what that means is acceleration is a measure of how quickly or how slowly or how fast velocity is changing. And remember, velocity can change in two ways. Velocity can change if you change the speed of the object or the person or whatever is moving. So it can either speed up or slow down, or it can turn. It can change its direction. If it's going straight, it can turn left or right or go backwards. So what is the relationship, therefore, between velocity and acceleration? Well, if there is no change in velocity, there's no acceleration. So if velocity remains constant, there is no acceleration. So an object moving at a constant speed in a constant direction, so if this object remains at 55 meters per second going north, if it stays that way, there's no acceleration. Opposite of that, let's say the object is moving at 55 meters per second in a circle. That means it's constantly accelerating. Even though the speed remains the same, because it's constantly turning, it's changing its velocity. And if it's changing its velocity, it's accelerating. So something can be going the same speed and accelerating. So we can calculate acceleration from velocity and time. So the change in velocity can be found by comparing the initial velocity with the final velocity of a moving object. So if we're going to draw it as a triangle, I like to abbreviate. I write VF minus VI over time, T for time. So acceleration is the final velocity minus the initial velocity divided by time. The units we use, if you recall, for speed and velocity are meters per second, and time is seconds. So acceleration is going to be meters per second, or meters per second every second, or meters per second squared. There are different types of acceleration. There's positive acceleration and negative acceleration. Positive acceleration. Now, when we talk about positive in physics for our units for now, I want you to think of going in the same direction. So let's say we start forward. Anything that says positive is going to be in the forward direction. Anything in negative is going to be saying in the opposite direction. So negative merely means opposite in this unit. So positive acceleration indicates that an object is speeding up. Acceleration occurs in the same direction as the original motion, which would be the positive direction. So it's going to be indicated by a positive sign. Okay, so if acceleration is occurring in the same direction as the motion, this object is going to speed up. Negative acceleration indicates that the object is slowing down or moving in the opposite direction as the original motion. Acceleration is opposite to the original motion, or negative. Okay, so acceleration in the opposite direction of motion slows down. Acceleration at a right angle to motion causes a change in direction but not speed. Leads to a change in direction but not the speed. Here's the example of what we're talking about here. So when you see acceleration in the same direction, so this is positive acceleration, if it occurs in the same direction as the motion, you'll notice these arrows, the longer the arrows, the greater the speed. Acceleration occurs in the same direction, so it gets faster. Acceleration in the opposite direction, which is known as negative acceleration, causes the object to slow down. And here you have acceleration at a right angle. So if it pushes on the object from one side, it's going to move to the opposite side. If you have any questions, please write them down and bring them in and come ask us. And as we're working through these task lists, we'll be happy to discuss any questions you might have with you, okay? We'll see you tomorrow. Take care.